Okay, so we will again, what we will do is we will revise the previous part, what we have done in the last class, and then we will proceed ahead. Okay, so in the last class, I told you about that there are certain divisibility rules. So the divisibility rule of 2 is what? So I shared you the picture as well, I think PDF. The divisibility rule of 2 says that any number which ends with 0, 2, 4, 6 or 8 will be divisible by 2. When I say it is divisible, it means it comes in the table of 2, multiplication table. It is a 2 is a factor of that number. And why it is required? Just by looking at the number, we can easily say that this number is divisible by 2, and the unit digit of those numbers are 0, 2, 4, 6 or 8. Such numbers are known as even numbers. You remember that? And the numbers ending with 1, 1, 3, 5, 7 and 9.
You're breaking up. You didn't say that. Well, like you're breaking up, kind of.
Just give me a minute.
Okay.
Let me check my net connection. Can you hear me now?
Okay, wait. Yeah, I can hear you now. Wait, huh? It's still kind of breaking up.
It's breaking up. Can you check?
Like, I can't hear you. What?
Okay, I am not saying anything. Right now, I am saying something. Are you able to hear me?
Yeah, now I'm able to hear you clear.
Okay, fine. So I was telling you that the divisibility rule of 2 we wrote in the last class. A number is divisible by 2 if the last digit is 0, 2, 4, 6 or 8. And such numbers we are known as even numbers. You remember that?
Yeah.
Okay. Then I taught you about the divisibility rule of 3. And before knowing you about the divisibility rule of 3, I told you about digital sum. You learned that digital sum. What is digital sum?
Yeah.
By adding all the digits of a number. And if you add all the digits of a number, if the digital sum is 3, 6 or 9, then the number is divisible by 3 as well. If it is not 3, 6 and 9, it is not divisible by 3 anymore. Then I told you about the divisibility rule of 4. If you remember, I told you about the so for this we will write in short. I will write digital sum is 3, 6 or 9 even numbers. The divisibility rule for 4 was last 2 digits. What is the divisibility rule of 4? Last 2 digits are divisible by 4. And do you know how we checked it? How we checked whether this number is last 2 digit is divisible by 4 or not? What was the rule?
Like how you check this? What do you mean?
So we broke it down into 2 places. We broke.
Oh yeah.
So if the ones place is 0, 4 or 8,
It's even.
the tens place must be an even number.
Yeah.
Or if the ones place is 2 and 6, the tens place must be an odd number. Are you getting it? Do you remember this?
Yeah. I'm just gonna write it down one more time.
Yeah, please write down.
Okay.
Okay. Now, when was the number is divisible by 5? When the last digit is when the last digit is 0 or 5. When the last digit is 0 or 5.
0.
Okay, now when is the number divisible by 6? What is the divisibility rule of 6? You know that?
Divisibility number of 6. Like, if the number ends with 2, no, ends with. If the number ends with 2,
Then 22.
4,
22 is
huh?
22 divisible by 6? It ends with 2.
No. Oh, no.
34 ends with 4. It is divisible?
Yeah.
No. So that won't work. Then what else you think? What else you think? How can you say a number is divisible by 6? Okay,
Any
fine.
number that
Okay, leave it.
ends with 6.
Okay, so let's leave that. We will come to that again. Don't worry for that. But before that, I would like to know whether you know about what are prime numbers or not.
Yeah.
Tell-
You explained it last class, right? They're like all the numbers that you can divide by two factors.
Okay.
That have two factors.
So, can you give me some examples?
Examples like maybe when you're doing division, if you have a remainder 2, and that's gonna be 3 factors, so it'll be composite number.
Okay. I wanted to write all the numbers from 1 to 100 like the way that I have written here. Please write down.
Okay.
In the same way, you have to write from 1 to 10 like this, then 11 to 20, then 21 to 30, then 31 to 40, then 51 to 60, followed by 61 to 70, then 71 to 80, then 81 to 90, and 91 to 100.
Can I get some water real quick?
Yes.
Hmm. What's 100? 100. What?
So today we have a task to remember the prime numbers from 1 to 100.
Okay.
Okay, that's a very important task. So do you have an idea how many prime numbers are there from 1 to 100?
No.
Okay. So up to which number you have written?
So far 62.
Okay, fine. Go ahead.
What? Go ahead. Talk. Okay, I wrote.
Okay, fine. So first of all, again, I would like to revise whether which number is a prime number. A prime number is a number who has got only two factors. The
Wait,
one,
what? Two what?
the prime
Two
numbers,
factors. Yeah, two factors. Yeah.
two factors. One is one and one is itself, the number itself. Let me check if my mic is working fine.
Yeah.
Okay. Okay, so the first prime number, the lowest prime number is 2. The lowest prime number is 2. Okay, so 2 is a prime number. Are you getting it?
Yeah.
Is 1 a prime number? The answer is no. 1 can never be a prime number because 1 has got only one factor, the 1 itself. But
Oh, yeah.
2 has got two factors, so 2 and 1. 1 into 2 is 2 and 2 into 1 is 2. So since 2 has got two factors, so 2 is a prime number. What about 3? Can you tell me, is 3 a prime number?
Uh, mm, No. Wait, actually, 3 can be divided by itself
Okay,
and 1.
1. Is there any other number which can divide 3?
Like, yeah, 6.
Can
Like,
no, you have to
3
understand. A number which is a
What?
factor and a multiple. Is 3 a multiple of any number? Does any number, suppose I write 6 into something is 3. Can you tell me, is there any number which multiplied by 6 to give you 3?
Oh no.
No. So 3 is divisible by only two numbers, that is 1 and itself. So 3 is
Yeah.
also a prime number. What about 4? Is 4 a prime number?
Oh no, because you can divide it by 2.
I can divide it by 2. Very good point. So is the only 4 that I can divide it by 2, or all the numbers ending with 4 can be divided by 2?
All the numbers ending by 4 can be divided by 2.
Because that is the divisibility rule of 2. Okay. What about 6? All the numbers ending with 6, can it be divided by 2?
Um,
Because that's the divisibility rule of 2. A number ending with 6, can't it be divided by 2? In the first point I made that a number is divisible by 2 if the last digit is 0, 2, 4, 6 or 8. So a number ending with 6, will it not be divisible by 2?
No, it can.
It can be. What about the numbers ending with 8?
Yeah, they can also be divisible by 2.
What about the number ending with 0?
They can. Actually, yeah, they can.
And what about the number ending with 2 other than 2? So they are also, so such numbers can never be a prime number. So I am ending it, see this. So these numbers can never be a prime number. The number ending with 2, the number ending with 4, the number ending with 6, the number ending with 8 and the number ending with 0. They are never prime numbers except 2. So even numbers are divisible by 2, alright.
Okay.
Now you know what is the divisibility rule of 5? Tell me what is the divisibility rule of 5?
Anything with 5 or 0.
Okay. So 0 is already been crossed off. So the numbers ending with 5, below 5, can it be divided by 5?
Well, all the numbers ending by 5?
Yeah. So all the numbers you see
Yeah.
ending with 5, I am removing all those numbers because all those numbers will come in the table of 5.
Oh yeah.
Okay, so they can
They
never,
can all be by 5.
so they can never be a prime number. So I am cutting those numbers as well. Are you getting it?
Yeah.
Now we have leftover number through which we will play and we will check whether those numbers are prime number or not. Okay, so I just want you to remember two multiplication table. One is for 3 and one is for 7. One for 3 and one for 7. Alright,
Well,
let us start.
what do you mean 1 for 3? One
Okay.
multiplication table.
Okay, I am asking you to remember two multiplication rule for, so 1 for 3. 1 for 3 means you know the divisibility rule of 3. The last, the sum, the digital sum must be 3, 6 or 9. There is no divisibility rule of 7. So you have to understand the table of 7 up to 100. Means 13 into 7 is 91. You can write it out. 13 into 7 is how much? 91. Yes. It's an important number. 13 into 7 is 91. So what we are going to do now is we will check for the number is prime or not from the remaining numbers. So can you tell me in the first row, we will go row wise. Can you tell me in the first row, apart from 2, 3, 5 and 7, is 9 divisible by 3?
Yeah.
So I'm crossing that 9. So from the first row, I got only 4 numbers: 2, 3, 5, 7. You can write these 4 numbers and you can cross all other numbers. You can encircle these numbers. You have written 2, 3, 5 and 7. These 4 numbers are prime numbers. These 4 numbers are prime numbers. Alright.
Yeah.
And now you have to check only with 2 tables. Either you check it with 3 or you check it with 7. That's it. Only with 2 multiplication tables you have to check, with 3 and 7. Now in the second row, from the remaining numbers, can you tell me, is any of these numbers divisible by either 3 or 7? Is 11 divisible by 3?
No.
Is it divisible by 7?
No.
So 11 is a prime number. What about 13?
Yeah. No.
So it is also a prime number. What about 17?
No.
So it is also a prime number. What about 19?
No.
So it is also a prime number. So in the second row also, we got 4 more numbers. Please write it down: 11, 13, 17 and 19.
Okay.
Coming to the third row, can you tell me the 2 numbers which are divisible by 3 quickly?
21 and 27.
Very good. So you can cross 21 and 27 because they can't be prime numbers. They are divisible by 3. So the remaining numbers are prime numbers. So you are left with 23 and 29 because they are not divisible by 7 as well. In the next row, can you tell me a number which is divisible by 3?
Yeah. 33.
Very good. And there will be one more number, 39. 3 and 9. The number having 3 and 9 are always divisible by 3. So the leftover number are 31 and 37. Are you getting it?
Yeah.
Okay. In the next row, can you tell me any number which is divisible by 3?
Yeah. 43.
How can 43 be divisible by 3?
No, not 43. 40. No. We are also doing 7, right?
Yes.
Yeah. So 49 is divisible by.
Very good point. Very good point. So 49. So we will just hide 49. It is not a prime number. So we are left with now 3 numbers, that is 41, 43 and 47. In the next row, can you tell me a number which is divisible by 3?
Oh, wait. Mm-hmm. Oh, what? Next row?
Yes.
No, I don't think so.
Any number divisible by 3? Do you know the digital sum of these numbers? Have you added them?
Yeah. So, wait. 51 is 6.
So if 51 is 6, then it might be divisible by 3 for sure.
Yeah.
What about 57?
No.
What is 5 plus 7?
What? Oh, wait. 57. Sorry, I was looking at 53. Yeah. Yeah, 57 is.
So that means we are
59.
okay. What about 7? They are also not divisible by 7. So we will write 2 numbers more, 53 and 59. They are also prime numbers.
Yeah.
In the next row, can you tell me 2 numbers or which are divisible by 3?
Yeah, 63 and 69.
Wonderful. So 63 and 69. So the leftover numbers are prime numbers. We can write it as 61 and 67. In the next row, 71, 73, 77, 79. Can you tell me a number which is either divisible by 3 or divisible by 7?
Yeah. So 77 is divisible by 7.
Wonderful. So the remaining numbers are prime numbers 71, 73 and 79. Can you tell me in the next row what are the numbers which are divisible by either 3 or 7?
Yeah. 81
Very good.
is divisible. And yeah,
So the numbers left are 83 and 89.
8, 89.
Can you tell me in the next row the number which are divisible by 3 and 7?
What in the next one?
Yeah.
Oh, yeah, sorry. Yeah, 93 is divisible.
Okay.
And 90. No, yeah, 99 is also divisible.
So have you checked by 3 and 7 both?
Oh, and 7. Yeah, I've checked by 3 and 7.
See, I made you write this in the beginning of when we
Oh.
started. I made you write in the
Oh,
beginning
yeah.
itself, and then also you forgot. This 91 is also divisible by 7. All right.
Yeah.
So it looks a prime number. It is not a prime number anymore. So the only prime number in the last row is 97. Please write it down. Write down all the prime numbers. These are 25 prime numbers.
Yeah, I wrote.
Done?
Yeah.
Okay. So now, so here is a test. Okay. So what is the test? The test is like you have to write these numbers in 30 seconds. Not now, but how to write it, I will show you. So what we can do is you can anytime put on a timer. Okay, and you have to remember all the prime numbers from 1 to 100 and you have to write it. And if you see the pattern, I will show you the pattern as well. You can see the first row, the first two row has 4 and 4 prime numbers. The next row keep having 2, 2 and then 3, 2, 2 and then 3, then 2 and 1. Okay, and if the first number is ending with 3, automatically the second number ends with 9. So if you remember the first number 23, you can write the second number. If the first number ends with 31, 1, it ends with 7. So you just see the difference is 6. Here the difference is 6. In the row of 3 numbers, you already know that 49 is not a prime number. If you look at these numbers carefully, you can find that there are only 4 kind of prime numbers ending with 1, 3, 7 and 9. There are only 4 kind of prime numbers. They are either ending with 1, 3, 7 and 9. Rest all numbers can never be a prime number. A number ending with 2 can never be a prime number. A number ending with 4 can never be a prime number. A number ending with 5 can never be a prime number. A number ending with 6 can never be a prime number. Number ending with 8 and 0 can never be a prime number. So there are only 4 kind of prime numbers. In those 4 kind of prime numbers, you will see the maximum either you are having 2 prime numbers or 3 prime numbers. So 3 prime numbers are in the row of 40 and 70. Rest all you are having only 2 prime numbers, and if the first prime number is ending with 3, the other is ending with 9. So you have to write this. Okay, let me show you how we are going to test it. You can test yourself after the class anytime whenever you are free. Okay, so I am writing like this. So you will write 2, 3, 5, 7, then 11, 13, 17, 19, then 23, 29, then 31, 37, then 41, 43, 47, then 53, 59, then 61, 67, then 71, 73, 79, then 83, 89, and then 97. I took 26 seconds, you have to take 30 seconds. Not more than that. You have to be thorough with all the prime numbers from 1 to 100. It's very much required.
Yeah. I'll try practicing with that.
Okay. So let me see if you can speak by just looking at it in 15 seconds. In 15 seconds is a verbal test. In 30 seconds is a written test. Okay, you can test yourself. So right now I am giving you 15 seconds to see whether you can say by looking at it or not. So your time starts now. Say.
Wait, say what? Say that.
Okay, like this. I am going to show you then. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97. I took 10 seconds, you have to take 15 seconds.
15 seconds. Okay.
Okay?
I'll try.
Okay, yeah. Shall I start? So your time starts now.
2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 44, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 87, 99. 97. No, what? 97.
Okay, you fumbled somewhere. You said 83 and 87 again. It is so you are looking at it. So you have to remember it and then you have to speak. Okay, this is 89. All right.
Oh.
This is 89. Okay. 87 is not a prime number. I told you the number ending. If the first number is ending with 3, the second number is ending with 9. If the first number is ending with 1, the other number is ending with 7. You can see the pattern. You can see the pattern. 31, 37, 23, 29, 41, 43, 47, because 49 is a prime number. All right. So you can prepare a test for this. In the next class, I'm going to ask you. You have to answer me in 15 seconds. All the prime numbers.
Okay.
And you have to write in 30 seconds. So you can have a practice of your own at your own time. You understood what I want?
Yeah.
Now why I want this? I want this because sometimes you might be getting a number like this. And if you don't know that 19 is a prime number, by which number it can be divided. So if you know that it is a prime number, you can immediately check with the table of 19. And you can break it down, simplify the number. So that can only be done if you know the multiplication table of prime numbers and you must remember the prime numbers. Sometimes you may be given the question like this, under root of 75. I don't know whether you know about under root or not.
No.
Square root, you haven't heard about square roots? Squares?
Oh yeah, square root we've heard, not under.
Under root is same as square root. Okay, under root is also known as square root only. Cube root.
Yeah, we haven't worked on square roots still.
Okay, fine. So you know about squares. Up to what number you remember the squares?
Squares?
Like 2 into 2, 3 into 3, 4 into 4, 5 into 5. Up to what number you remember? Okay, you write with me, along with me. Let's today make you learn the squares up to 50. So, what is 1 square? What is 1 square? 1 into 1?
Oh yeah, 1.
1. You write along with me. 1 into 1 is 1. What is 2 square?
Yeah.
4.
They call it something different here, so when you said that, I got confused.
It's okay. They might be calling it exponent.
Yeah, we never call it square.
So, what do you call square as this one?
Yeah.
So, what do you do? What is the area of this? Suppose the length is 3. So, what is the area of this?
9.
So, what you have done? 3 into 3.
Yeah.
So 3 into 3 is means what? 3 into 3 is what? So that's why we say it is square.
Yeah.
Square. The area. You see the area. 3 multiplied by 3. What about 4 multiplied by 4? 4 square is how much?
16.
Very good. 5 square is how much?
25.
Very good. Write down.
Okay.
Can you tell me what is 6 square?
36.
Very good. What is 7 square?
49.
What is 8 square?
72. No, sorry, not 72, 64. Yeah, I was just couldn't. Wait, can I write this before answering?
Yeah. Okay, fine. You said 73 just now. I taught you 73 is a prime number. You have to remember that.
No, I said 72 by accident because I was looking at the exponent.
Okay, it's okay.
Like it's to the square of 2. So by accident I said 72.
Okay, it's okay.
Brings me right
But they stopped at 10
Yeah.
Okay.
We stopped at 10 square.
No, we will go up to 50. Don't worry. We will go up to 50.
Okay.
Okay. So can you find the difference between the first two numbers?
The difference? Yeah, it's 3.
What about the next two numbers?
5.
What about the next two numbers?
7.
Next two numbers?
9.
Very good. Next.
Oh wait, it's like a kind of like a pattern.
Yes.
It's always increasing by 2.
Yes. And if I ask you find the second difference, you will find the second difference is always constant.
Yeah.
Why the second difference is 2? Because we are finding the square. If we are going to find the cube, then the second difference will be 6. It will come. We will learn that later on. But right now you have to understand that the difference between any two consecutive square is an odd number. Can you see that?
Yeah.
The difference between any two consecutive squares is how much? Odd number.
Yeah.
So you can see 2 plus 1 is how much?
3.
3 plus 2 is how much?
5.
5 plus 4 plus 3 is how much?
7.
Okay, so if I ask you what is 22 square minus 21 square? Do you really need to calculate this or you will add the two numbers? You see, 3 plus 2 you added 5, 4 plus 3 you added 7, so 22 plus 21 is how much?
Yeah, that's 43.
So you can check yourself, the answer will be 43. How?
Oh.
So 22 square is 484, 21 square is 441, you subtract it and you will get 43.
Oh.
So the difference between two square can be calculated, two consecutive squares can be calculated just by adding the numbers. And you can write this down. The difference between two squares of two consecutive numbers can be found by just adding them. and it is always an odd number. If you add two consecutive numbers, anyway you are going to get just the odd numbers, because one of the number is even and the other number is an odd number. The difference between the squares of two consecutive numbers can be found by just adding them. So can you tell me what is 73 square minus 72 square?
Yeah, that's 145.
Wonderful. See how fast you have done it. You can write some examples as well. 81 square minus 80 square.
Wait, 145. So, I have a question about 73 and then minus 72. So, when you do that, what about the square? Like, don't you have to, you don't carry it on, right?
What?
See the definition there.
Yeah, so you don't like, you just forget about the 2, right? Whenever you're doing that.
Yeah. So it is working for only two consecutive numbers, not for all the numbers.
Oh.
If you want to know how it is working, I can tell you that as well. See how it is working.
Yeah.
So, do you know about distributive property?
Yeah.
Can you tell me, can you multiply these two numbers? Have you learned this before? What is x plus y into x minus y? You know how to multiply these, a variable by a variable? No? Okay, fine, don't worry. Okay, we will come to that, don't worry. If I ask you, suppose I ask you 10 plus 2. Okay, you know about this property, distributive property?
Yeah.
What is distributive property?
So it's like a property where you distribute one number among many.
Okay, so like if I say 2 into 99, it can be written as 2 into 90 plus 9. It can also be written as 2 into 100 minus 1. Are you getting this?
Yeah.
So what happens? First 2 is multiplied by 100 and then 2 is multiplied by 1, right?
Yeah.
So same goes with the variables as well. So if I ask you what is x plus y and x minus y. So first this x will be multiplied by green x minus y. And then the second y is going to be multiplied by x minus y.
Yeah.
Then when you multiply x by x, how much you will get? X square. And then x into minus y is how much? Minus xy.
Yeah.
And then y into x is how much? Yx. And then y into minus y is how much? Minus y square. So minus xy and plus xy will get cancelled out. So you will be left with x square minus y square. So x plus y into x minus y is how much? X square minus y square. So suppose you have 73 square minus 72 square. So you can relate this with x square minus y square. So how much you will get? You will get 73 minus 72 into 73 plus 72. So 73 minus 72 is how much? 1.
Yeah.
And 1 multiplied by, if you add them, you will get the same number. So actually what we are doing it, we are just adding the numbers to find the resultant. So it will come 145 only. Did you get that?
Yeah.
So the difference between the squares of two consecutive numbers can be found by just adding them. So 81 square minus 80 square will be how much?
Oh, 161.
Very good. Okay, one more pattern. Can you find the pattern in the table of squares? You look at the ones place. You look at the ones place. Can you see any pattern? Some numbers are repeating.
Yeah, so like after
5.
what? Yeah, after 5 we see the end of 20, like, yeah, 5 and 25, they're the end of 25 is 5 and the end of 36 is 6.
Okay, so can you see the number is ending with either 6, the number is ending with 9, the number is ending with 4, and the numbers are ending with 1.
Oh, yeah.
So the squares of a number can get only 6 kind of numbers. Either they can end with 1, 4, 5, 6, 9 or 0. The square of a number can end with 1, 4, 5, 6, 9 and 0. Can you see that?
Yeah. Wait, but that's not, but it can also end with other numbers, right? Or are those the only numbers it can end with?
No, it cannot end with, it can never end with 2, 3, 7 or 8. You can never find a square whose last digit is 2. You can never find a number whose last digit is 3. You can never find a square number whose last digit is 7 or 8. Because you multiply 2 into 2, you will get 4 only. 3 into 3, you will get 9 only. Suppose 13 into 13. So the first digit will be 9 only. Let us suppose 17 into 17. The first digit is going to be 9 only. 7 into 7 is how much? 49.
Yeah, 14.
49, not 14.
Times.
Yes. What about 12 times 12? So 2 into 2 will be 4. Let us say 15 into 15. So 5 into 5 means it will end with 5. So it will never, none of the number multiplied by itself will give you 2, 3, 7 or 8.
Yeah.
So they can never end with 2, 3, 7 or 8. So if it happens to be a number given to you ending with 2, 3, 7 or 8, you can immediately wipe it off because those numbers can never be a square of any number. Alright?
Yeah, got it.
Okay. So we've got very less time. Now it's 10 more minutes left. Let us revise what we have learned. So the multiplication table of 2, the number is going to end with an even number. The multiplication table of 3, the digital sum must be 3, 6 or 9.
9.
The divisibility rule of 7, the last two digits are divisible by 4. How you will check it? If the last digit is 0, 4 or 8, the previous number has to be an even number. If the last digit is 2 and 6, the previous number has to be an odd number. The number ending with 5 or 0 is divisible by 5. Okay?
Yeah.
And then comes the prime numbers. How many prime numbers? 25 prime numbers. From 1 to 100, how many prime numbers are there? 25 prime numbers, and you have to write in 30 seconds. I told you the logic behind all the prime numbers, how to check it. So I eliminated the number ending with 2, 4, 6 or 8 and 0. I eliminated the number ending with 5. And then I eliminated all the numbers which gives the digital sum of 3, 6 and 9. And then I also eliminated the number ending with divisible by 7. So 91 was a one crucial number. If you remember this, 91 is also not a prime number. It looks like it's a prime number, but it is divisible by 7. 13 into 7 is 91. So every row has got two numbers at least. You can see two numbers are there, 2, 2, 2. only the row of 40 and 70 get 3 numbers, and the row of 90 has got only 1 number. These numbers are prime numbers. Alright?
Yeah.
Then I made you learn the squares of a number and told you a trick as well. The trick is to find the square difference of the squares of two consecutive numbers. So how to find them? Just add them. So whenever you find in your calculations, anytime you will get a calculation like this for sure. Some or the other time you will get it. Don't keep calculating the squares. Just use this trick. Just add them. In the last class, I told you about the multiplication table of 99. You remember that?
Oh yeah. I need a revision on that.
Can you tell me 99 into 64?
Yeah, I think I need a revision on that.
Okay, you need a revision on that. So let's revise.
Like, when you understand one, remember last time you come on, remember?
The 26, sir. You told that, but 99 into 26.
Okay, let us do 99 into 64. So it can be rewritten as 64 times 100 minus 1. Any doubt in this?
No.
It can be written as 6400 minus 64. Any doubt?
No.
It can be written as 6300 plus 100 minus 64.
Yeah.
It can be written as 6300 plus 99 minus 63. Any doubt?
No.
So the first two digit, you can see it is reduced by 1. The first two digit is reduced by 1, and the next two digit you will get by subtract, just making it 9. So 6 can be, what should be added to make 6 9? So 3. And what should be added to make 3 9? So 6. So the answer is 6336. The answer is 6336. Are you getting it?
Yeah. No, because the reason why I was asking, when we did the same method with 26, it didn't work. In the calculator,
Come on. Come on, it will work for sure. 99 into 26. So 1 less than 26 is how much?
25.
And then 2 must be added, what, to make it 9?
So 2, 7.
And what should be added to 5 to make it 9?
4.
So I think the calculator in all the world is same only. So if it is here, it is giving 2574. In your calculator also, it will give 2574 only. It will.
Let's check again, because we got the same answer, but on the calculator it showed something else.
So
No, this edit, right? Same calculator. Maybe that.
maybe you have mistyped any button. It may happen, or the result from the previous, it took the result from the previous calculation. You can recheck your answer. Anytime you are getting a different answer, maths is same everywhere, so it is not going to change. Okay, you will check every time, it will come the same. You have to trust this result. All right. In fact, 99 into 99, see, 99 square, you can remember this as well. So what you will subtract from 99? 1 subtracted from 99 is how much? 98. And what should be added 98 to make it 99?
9801.
So let's check it out. See this?
Yeah.
It works for all the 2-digit numbers. In fact, not only 2 digits, for 3 digit as well. Suppose I give you 123 multiplied by 999. So you make this 122 and then tell me what should be added to 1 to make it 9? 8, 2, 7, 7. So let's check it out. 123 into 999. See, 122, 877. It works for 3 digit, 4 digit, 5 digit, any number of digits. That's the beauty of maths. Alright.
Yeah.
Any doubts? So all these things you have to revise. Please make a note. You have got one free day as well, I think. No, we have got class on Saturday. Yeah, so one day is free. Have you tried doing C1, C2, C3, C4?
Oh yeah, I finished.
Okay, then start with D1, D2, D3, D4. Go from D. Start doing D exercise. All right.
Okay.
It's decimals. If you are having any trouble in any of these exercises, you can let me know. You can just click the photo, or you can watch the video tutorial as well. There are very good video tutorials in those sections. Just keep doing it. We have to go one by one, and as soon as you will gain some confidence in some of the sheets, I will switch it to the next level. All right. This is like a
Yeah.
warm-up exercise. Okay. And please remember all these multiplication tables and divisibility rules. Monday you will have a test for the prime numbers.
Yeah.
In 15 seconds you have to say without looking at it.
Okay.
Chalo, bye.
Yeah. Done.
Bye.
Thank you.